March 8th through the 12th. This is lesson 33. Alright, these two lessons that we're going to do this week, we're going to do lesson 33 and lesson 34. They are a review of pretty much everything we've done. This is the end of module 1. So we're just going to kind of look at this. I will tell you, lesson 33, the very first page of your lesson, just kind of goes over everything that we've talked about to this point. I'm not going to spend all of this time reading to you because you guys are big enough that you should be able to read this. If you want somebody else to read it to you, you can. That's fine. I'm not worried about it. But please make sure you take time to read through this. Like I said, this just kind of reviews everything that we've talked about up to this point. Alright, so make sure you have read the first page of this lesson. If you want to pause the video, you can do so. But then we're just going to kind of go through this. This gives us notes. We have facts and properties. We have guided questions or applications. In other words, putting whatever it is we're talking about to use. And then any kind of notes that we want to take, answers, that kind of thing in the last column. Alright, so let's just kind of run through these and look at them. Two angles that form a linear pair are supplementary. Linear pair, remember that means they form a straight line. Supplementary meaning 180 degrees. So if I'm looking at this, I have a figure. If this is 133 degrees, how would I figure out the missing angle B? I would do 180 degrees minus 133. Which gives the measure of angle B being 47 degrees. Alright? Let's look at the second one. The sum of the measure of all adjacent angles formed by 3 or more rays with the same vertex is 360 degrees. Alright, so we've got to remember adjacent means that they share a side. So these two angles share a side. They're formed by 3 or more rays. These are rays, and they have the same vertex. So here is my center, that is my vertex. That equals 360 degrees. So how would I find the measure of the missing angle? Well, I would add 147 and 133. So that would give us 280. And then I'm going to subtract 360 minus 80. And that means the measure of angle G is equal to 80 degrees. Alright, vertical angles have equal measure. Use the fact that linear pairs form supplementary angles to prove that vertical angles are equal in measure. Well, so let's just think about this. It kind of wants us to do a little bit of a proof. So I need to come up with two angles. So we'll just use the measure of angle W plus the measure of angle X is 180 degrees. That's my linear pair, and that they are supplementary. And it says prove that vertical angles are equal in measure. Alright, so now I can do, we can say that the measure of angle Y plus the measure of angle X equals 180 degrees. Alright, and since they both equal 180 degrees, I know that the measure of angle W plus the measure of angle X is equal to the measure of angle Y plus the measure of angle X. And then if I subtract angle X from that, I get the measure of angle W is equal to the measure of angle Y. Alright, so those would be vertical angles. The bisector of an angle is a ray in the interior of the angle such that the two adjacent angles formed by it have equal measures. It says in the diagram below, segment BC is the bisector of angle ABD. What does it mean to bisect? It means to divide into two equal parts. It's telling me this whole entire angle is 64 degrees. So what is the measure of angle ABC? Well, all I have to do is divide 64 by 2, and that would be 32 degrees. The perpendicular bisector, once again, perpendicular bisector, dividing into two equal parts. Perpendicular means 90 degrees. Of a segment is the line that passes through the midpoint of the line segment and is perpendicular to the line segment. So let's look at this. In the diagram below, segment DC is the perpendicular bisector of AB, and CE is the angle bisector of angle ACD. It says find the measure of AC and find the measure of angle ECD. So I want to know what is this segment, and I want to know what is that angle. Couple of different things here. First of all, perpendicular bisector passes through the midpoint. So if this is the midpoint of my segment, then I know that segment AC would equal 12 centimeters, because this would be divided into two equal parts. If this part is 12, this one would also be 12. It also tells me that CE is the angle bisector, meaning it's going to divide my angle into two equal parts. If this is a perpendicular bisector, that means this is a right angle. So half of that right angle, half of 90 degrees, would be 45. So the measure of angle ECD is 45 degrees. All right. Let's look at the next page. All right. It says the sum of the three angle measures of any triangle is 180 degrees. Given the labeled figure below, find the measure of angle DEB. So angle DEB, I want to know this. And the measure of angle ACE, I want to know this. Explain your solutions. All right. Well, let's think about this. I've got some perpendicular bisectors here. I'm sorry, not perpendicular bisectors. I've got linear pairs here. So in order to figure this out, if it's a linear pair, it's 180 degrees. So 180 minus 130 would be 50. So this angle right here is 50 degrees. All right, so the measure of angle DEB is 50 degrees. All right, which then tells me that this is 50 degrees because of vertical angles. So therefore, 65 plus 50 is equal to 115. The three angles in a triangle equal 180. So 180 minus 115 would be 55 degrees. I'm sorry, 65 degrees. So the measure of angle ACE is 65 degrees. Okay? When one angle of a triangle is a right angle, the sum of the measure of the other two angles is 90 degrees. The fact follows directly from the preceding one. How is it simple arithmetic used to extend the angle sum of the triangle property to justify this property? All right, since the right angle is 90 degrees and the sum of all three angles are 180, then the other two angles must add up to be 80 degrees, or add up to be 90 degrees. So we're going to say since a right angle is 90 degrees, and the sum of the angles of a triangle sum to 180, the other two angles must add up to 90 degrees. Okay? So simple arithmetic there. An exterior angle of a triangle is equal to the sum of its two opposite interior angles. Alright, so in the diagram below, how is the exterior angle of a triangle property proved? So let's look at this. I am, an exterior angle is equal to the sum of its two opposites. So if this is an exterior, that means it would be equal to this. These two angles added together. Alright? So the sum of two interior opposite angles and the third angle of a triangle is 180. Alright, so I know that. So the sum of two interior angles and the third angle of a triangle is 180 degrees. Alright? Which is equal to the angle sum of the third angle and the exterior angle. So in other words, 130, these form a linear pair, so this would be 50, and I can add up 180 degrees, so 65 and 50 is 115, so 115, take that from 180, alright, that would be 65. And if I add 65 plus 65, I get 130. Alright? Base angles of an isosceles triangle are congruent. The triangle on the figure above is isosceles. How do we know this? Because the base angles are equal. We just proved the base angles are equal here. And we know, so therefore we know it's an isosceles triangle. All angles in an equilateral triangle have equal measures. If the figure above is changed slightly, it can be used to demonstrate the equilateral triangle property. Explain how this can be demonstrated. Well, the measure of angle AEC is 60 degrees, because if it's an equilateral triangle, so I can do 180 minus 120, which would give me 60 degrees. Alright? And then 60 plus 60 is 120. Once again, 180 minus 120 means that that also has to be 60 degrees. Okay? So therefore, they're all the same. Alright, last page. The facts and properties in the immediately preceding table relate to angles and triangles. In this table, we will review facts and properties of parallel lines and transversals. If a transversal intersects two parallel lines, then the measures of the corresponding angles are equal. Why does the property specify parallel lines? Well, if the lines are not parallel, then corresponding angles are not congruent. Okay? So it has to specifically tell me that they are parallel lines. I can have corresponding angles, but if the lines are not parallel, then they are not congruent. If a transversal intersects two lines such that the measures of the corresponding angles are equal, then the lines are parallel. It says the converse of the statement turns the relevant property into an if and only if relationship. Explain how this related to the guiding question about corresponding angles. Well, the if and only if specifies the only case in which corresponding angles are congruent. And that means that the lines have to be parallel. So the if and only if specifies the only case which corresponding angles are congruent. Alright, and that is only when the lines are parallel. If a transversal intersects two parallel lines, then the interior angles on the same side of the transversal are supplementary. This property is proved using, in part, the corresponding angles property. Use the diagram below, knowing that AB is parallel to CD, to prove that angle AGH and angle CHG are supplementary. Well, what do I know about angle AGH? Well, they are supplementary, which means that AGH, so the measure of angle AGH would be 110 degrees because they form a linear pair. Alright, so they form a linear pair. And if angle CHG is 70, then I know 180 minus 70 is 110. Because of corresponding angles. Alright, so measure of angle CHG is 70. So CHG, we figured out this is 110, and it says CHG would be 70 because of corresponding angles. Alright. And we're trying to prove that AGH and CHG are supplementary. Well, 108 or 110 plus 70 is equal to 180. So interior angles on the same side are supplementary. If a transversal intersects two lines such that the same side interior angles are supplementary, then the lines are parallel. So we're given the labeled diagram below. Prove that AB is parallel to CD. Alright, well, once again, I know that the measure of angle AGH is 110 due to linear pair. Alright, so I know that this one's 110 degrees due to the fact that it's a linear pair. And I know that angle GHC, alright, I know that angle GHC is equal to 70 degrees because of corresponding angles. Alright, or we can say due to vertical angles because we'll just use that. So due to vertical angles. Alright. So then AB has to be parallel to CD because of corresponding angles. We've got corresponding angles here. And I know that if my corresponding angles are equal in measure, then my lines have to be parallel. Okay? If a transversal intersects two parallel lines, then the measure of alternate interior angles are equal. It says name both pairs of alternate interior angles in the diagram above, and how many different angle measures are in the diagram. Alright, so name both pairs of alternate interior angles. Alright, so step 1, both pairs of alternate interior angles would be angle GHC so angle GHC and angle HGB. Alright, so this one and this one. And then we would have angle AGH and angle GHD. different angle measures are in the diagram? Well, we've already proven that there's only two different measures, and that would be 110 and 70. If a transversal intersects two lines such that measures of the alternate interior angles are equal, then the lines are parallel. Although not specifically stated here, the property also applies to alternate exterior angles. Why is this true? Alternate exterior angles are vertical angles to the alternate interior angles. So alternate exterior angles are vertical angles to alternate interior angles. You can go back up here in this and look. This exterior is vertical to this interior. This exterior is vertical to this interior. And that's all it's saying. Alright, guys, that's lesson 33. The next video will be lesson 34.